Let's look at a solution for the binary search function. So let's start with our tests here, and I'll use this one as an example. The inputs to our function are a list. The list is always going to be sorted. It's just going to be a list of numbers. And the reason that they need to be sorted will become obvious when I walk through how the algorithm is going to work. But for now, it's important to know that the input is always going to be a sorted list of numbers. And we'll also take a number that is in the list. We're going to assume that the number is in the list, and this is the number to find in the list. What we want to do is find the index of that number with our binary search method, and we also want to return the index and the number of attempts that it took to find that number. So essentially the number of guesses. Okay, and that'll become obvious what that means here. Important to note, this says, so in this case, here we have our list. This has 10 elements in it, 11, 22, 33, etc. I'm looking for the number 88, which is at the 7th index, and it says it took 2 attempts. It actually took 3, but our count for the number of attempts starts at 0, right? So our first attempt is attempt 0, and then our second is attempt 1, and our third attempt is attempt 2. Sorry, I'm confusing myself. Okay, so a couple of assumptions. Went over this. The list is already sorted. The element to find, which I'm calling target, TRGT for target, the target element to find is indeed contained within the list, and the counting index starts at 0. So these are a few important things to take note of. Okay, so let's start with a solution. Actually, let's walk through the algorithm. So a binary search algorithm works by essentially you start in your first guess is as close to the middle as you can be. Obviously, like odd numbers can't be evenly divided, so you have to do a little juggling with whether it's even or odd. But fortunately, what we can do is if a number ends in 0.5, we can just truncate it and find the middle that way based on essentially how, the length of the list. Right. So that's one way we can determine the middle for our initial state is get the length of the list over 2, the length of the list minus 1 over 2. Right. So in this case, and let me comment this out so I'm clear about what I'm talking about. So in this test, I have 10 elements in the list. So my maximum index is 9. Half of 9 is 4.5. We truncate that to 4. So our middle index is 4, which is the 5th element. 10 elements, 5th element's the middle. So that's going to be 0, 1, 2, 3, 4, 5 here. Or excuse me, 4 right here. So that's going to be our middle, right? So you can think about it like the way to determine the middle has to be not just relative to the length of the list, but it has to be relative to where our next guess has to be, right? So what we do is we start in the middle, we guess in the middle, and since our list is sorted, we can tell if the number that we found in the middle is smaller than our target number, then we need to go, our next middle point has to be up, has to be above, right? So how do we determine that next middle point? Well, we can think about a lower and upper boundary on the list that initially starts at 0, which is the beginning, and the length of the list minus 1, which is the end, right? Sensible start and end points, because those are the starts and end points of the list. So we'll start it at 0 and the length minus 1, and we'll determine the middle based on that. But if we move the upper portion down or the lower portion up, the middle has to be relative to both of those. So what we can actually do is imagine, and let's just plug in numbers here, right? So I'm going to call this lower equals 0, and upper equals, well, that'll be 9. Mid equals 4, and I'm just doing this. This isn't code. This is just taking notes for us for now, right? So in this case, our middle index is 55. This is too small, so we need to move the lower, our new lower, let's see, is going to be our old mid, which is going to be 4. Our upper stays the same. And then our mid is going to be the sum of upper and lower, which is 13, the sum of upper and lower over 2. So 13 over 2 is 7.5. Again, we're going to truncate the 0.5 and just cast that as an int. So we'll just end up with 7. Right? So that system is going to let us determine the midpoint every time. All right, so let's jump into it. So let's start laying the foundation here. So I'm going to start LWR for lower, UPR for upper, and we'll start those equal to 0, followed by len list minus 1. So lower and upper have their starting points, and then I'm actually just going to loop through a range of the len of the list here. So I'm going to say for count, and this is going to be our count. This will be the second element that we return. Remember, we want to return the index at which we found the target number and the count, the number of times attempts that it took to locate that target number, starting from 0, right? So fortunately, range gives me the appropriate indices starting from 0, so we'll just do that. Okay, so remember, the way of determining our midpoint is going to be determined dynamically every time based on our lower plus our upper, the sum of those. We need to do the sum first. So the sum of these over 2. And then since this will give us a float back, I'm just going to cast it as an int. You could do floor division, but my preference is to do int because that's how I've always done it. Yeah. Okay, so now we want to build in the logic for how do we change those partitions. So if our guess, what is our guess? Let's call this guess equals, let's call this actually mid. Our guess is our mid element, right? Now mid is just the mid index. So our mid element is going to be list sub mid, right? And I'm actually just going to use list sub mid, but we can just take note that that is indeed our mid element. So we can say if list sub mid is greater than our target number. So if the number that we guess, our middle number, is too large, then we need to move our upper boundary down to our mid. So we'll say UPR equals mid, and then we'll say else. If that's not the case, then we'll move our lower to equal mid. Now we just need to check mid. So we'll say if list of mid equals target, then we can return mid and count. Cool. Get rid of this comment. And let's submit it just for posterity or something. I'm using that wrong. I know I'm using it wrong. All right, cool. That works. All right, hopefully that was helpful. Feel free to DM me if you have further questions. Have a good rest of your day. Bye-bye.